Assalamualaikum and good day guys. In the video we are going to go back a little bit on the type of matrix, because I think that there are something that I've actually not emphasized previously. In one of the type of the matrix, which is on the Skew Symmetric Matrix. Okay, before we go to the Skew Symmetric Matrix, let's first look at the Symmetric Matrix itself. So for those who are not clear with it, it is actually called a symmetric matrix if the matrix after being transposed get the same matrix, the same element. For example, this is the matrix. Even when you transpose, you will get the same elements, right? Because the transposition, still if you transpose it, 1 2 become the column, 2 4 become the column, right? 1 2 become the column, 2 4 become the column. You still get the same arrangement of element. So basically this is example of symmetric matrix. So to show that a matrix is symmetric or not, you just need to do the transposition. Okay, so next, for the skew symmetric, right, I did told you that previously a matrix is called a skew symmetric matrix if when you transpose it, the matrix change to a negative form. Okay, for example, if you look at this, right, first we know that previously a symmetric matrix is a matrix when you transpose, it will still remain in the same arrangement of element, so resulting the same matrix. As for skew symmetric, they will still give you the same arrangement of element, but the difference is in the positive and negative of that element. Now if now for skew symmetric, when you transpose it, they will still be in the same arrangement of element, but the negative will now become positive, the positive element will now become a negative element. Let's look at the example here. So this is the matrix. So when you find the inverse, you'll see it still get the same in terms of number, they are still in the same arrangement, right? So we have 0 2 3 0 2 3 205 205 and 350 350. But if you see closely, you will notice that the positive and negative of each element has changed. For 0, it doesn't really matter positive negative, so it remains like that. But let's look for 2 here. At first it is negative. When you inverse it, when you transpose it, it becomes positive. As for 3, from positive become negative, 2 positive become negative, 5 negative become positive, positive become negative, and negative 3 become 3, negative 5 become 5. So actually for this one, what's negative become positive, what's positive become negative. That is actually one of the key to indicate it is a skew symmetric matrix. And one more thing that I not really emphasized before is the diagonal part. The diagonal elements should be, right, or must contain zeros. So when this is zeros, and the other condition is that they are in the elements are in the same arrangement, but the positive and negative of that elements has changed, that indicate skew symmetric, right? That is it for the additional video on types of matrix. Thank you.